Hey everyone, my name is Justin Koo, and today I will be showing the methods of integration. There are two methods that I will be covering today, and the first one is U substitution. We use this technique when we see a function and its derivative together, and we're going to try to solve this problem. Okay, we will start with writing down the question, which is this. So as I said, we want to use U substitution when we see a derivative and its function next to each other. So we can write it like this to make it clearer. Because the derivative of ln x is 1 over x. Right, so u equals to ln x, because this is the substitution method. So u, then you want to differentiate the u, so you get 1 over x. And then you want to move the dx over, like this. So now this is du. And now you integrate with the power rule. So, let's see. And then the next step is to sub this into the u. So you get this. So this is the first technique, the u substitution technique. Okay, moving on, we are going to the second technique, which is integration by parts. So this is the formula that we will be using and the problem that we will be solving. And we need to follow the LIAT acronym here, which is logarithm, inverse trigonometry, algebra, trigonometry, and exponential. And we go from top to bottom, whichever fits the category for the problem. It is going to be u. For example, ex is exponential, so it's going to be v, and x is algebra, so it's above of exponential in the acronym, so u is x, and then v will be ex. So let's try solving this. Okay, let's start by writing down the question first. X, ex, dx. Okay, we need to remember to use this acronym. So to know which one is u and v, for example, x is algebra, so u equals to x. And then e is exponential, so we know that a comes before e in this acronym, so u equals x, and the other one is v. So we want to differentiate this, equals 1, and du equals dx. And then dv equals to ex dx. And then we know that v equals to ex. Okay. Then we also need to remember to use this formula here. And now that we have everything, we can just sub into the formula. So u equals to x, v equals to ex, minus v equals to ex, du equals to dx. So we get x. So if you integrate ex, you still get ex plus c. So this is the answer. Okay, so now we have to verify our answer. And how we can do that is by differentiating the answer and seeing if you get the problem, the initial question to begin with. Okay, so now we will be differentiating this equation here. Okay, immediately plus c we cross off. And then for xex, we need to use this formula here. So x equals to 1, v just write without differentiating, and then u just write x, and then if you differentiate ex, you still get ex. So we get ex plus xex. And then ex, if you differentiate it, you still get ex, so it's still negative ex. So now we get xex, which is the initial question that we start with. So that means that our integration was correct. Okay, so now to conclude everything, U substitution is used when you see a function and its derivative next to each other. And integration by parts is a method for products of different function types. And we should always verify our results. So we always want to verify our integration by differentiating it to see if we get the initial question to begin with. Okay, thank you so much for watching this video. Hope you learned a lot.